Hello guys, welcome back to my channel. I understand that your exams are going on, so it becomes very difficult before your physics exams to revise all the chapters in a very less amount of time, guys. So here I am to help you, to give you one short formula revision list which will help you in scoring very good marks in your exams, plus making your concepts very easy for you guys. In previous lecture, if you guys have not seen, I will suggest you to see my previous lecture in which I made the formula list, last minute revision formula list for first three chapters, that is force, work, power, energy and machines. So I am here right now to give you one short formula revision list for the next four chapters, guys, that is refraction through plane surface, refraction through lens, spectrum and sound. Whenever I'm talking about refraction through plane surface, I understand, guys, it becomes very difficult for you to remember all the formulas. There are so many formulas in these chapters. We have very less formula for the next three chapters, but we have a lot of formula for this chapter. So it becomes very difficult for a child to revise everything, the concepts, the formulas, the tricks, everything before the exam. So I am here to help you. Again, as I said, पढ़ोगे तो बढ़ोगे, ठीक है. So I will be giving all the details, all small tricks, ठीक है. तो I will suggest you to go through with all the four chapters, ठीक है. And whenever I am teaching you guys, you can pause and write the all formulas in your book. I want you to write the formulas just because it becomes very easy for a student when they are writing formula in their own handwriting, and becomes easy for them to revise from their handwritings. Okay, you know how my handwriting is. But I want you to write in your handwriting, so it becomes easy during exams to recall from your own handwriting. Okay, and in case if you find some formulas difficult, anything, you can ping me. If possible, I will just help you guys. Okay, so let us start with fourth chapter, guys. Okay, refraction through plane surface. Refraction through plane surfaces. Baapre, you have so much formulas, guys. इतने ज़्यादा formulas है ना इसमें, especially for refractive index. तो ये topic में I will also teach you what is a refractive index, and then we will move on, because you will see at least 7, 8, 9 formulas for only one quantity, that is refractive index. ठीक है. Let us start. Number 1, refraction to plane surface. First formula is mu equal to sin I upon sin R. What is this mu? This mu is called as refractive index. Refractive index. What is this refractive index? I will just explain you so that it becomes easy for you during exam. So look in this diagram, guys. So see, refractive index. Basically, refractive index is a ratio of sine of angle of incidence to sine of angle of refraction. I is angle of incidence, R is angle of refraction. What is angle of incidence? This is normal. Imagine this condition, guys. Imagine this condition. The light is falling on the surface. This is vacuum. This is some any medium, water or gas or solids, any medium you take. Okay, na? So these are two different mediums. This is the interface of that medium. So light is falling on this medium. It is changing its path. That is called as refraction. So angle between incident and normal is angle of incidence. Angle between incidence and refracted rays, angle of refraction. You know this, guys. Okay. So we will take the ratio. We will take sine of this angle. Suppose this is 30 degree. Imagine this is some other degree, 15 degree. Take this value, sine I upon sine R. You will get basically a constant value. Anything 1, 2, 0.8, anything. Okay. Now what you do, guys? You change this angle. Suppose the angle is like this. Now the angle is like this. Now this is the angle of incidence, this part. Same, and you will see the angle of refraction will also change. Anything, you will see the angle will be changed. Now, for this angle of incidence and for this angle of refraction, for same pair of media, in same, for example, as I said, this is this is vacuum and this is glass. For same pair of media, though the angle of I and R is changing, the ratio will be same, and that ratio, okay, we know by the term called as refractive index mu. This is called as mu. Okay, so I hope you understand this. Okay, so it becomes very important for you guys to understand what is refractive index. Why? Now you will see how many formulas we are going to solve. Okay, so let's go on. First formula mu is sin I upon sin R. Number 2, mu is C upon V. Easy guys, what is C? C is called as speed of light in air. What is V? V is called as speed of light in medium. What do you mean by medium? If it is water, light is traveling from air to water, so here it will be water. It is traveling from air to glass, here it will be glass. I hope you guys know the values. Like speed of light in air or vacuum, it's fixed, that is 3 into 10 raised to 8 meter per second. Water, fixed 2.25 into 10 raised to 8 meter per second. Glass, 2 into 10 raised to 8 meter per second. So as you see, the more denser the object, the speed of light is decreasing. Okay? So if they are asking refractive index in water, simple, C upon VW. C, air or vacuum, same value, 3 into 10 raised to 8. Water guys, water में 2.25 into 10 raised to 8 डाल दो, take the ratio, you'll get the answer. Keep this in mind. Okay? So these are the two first basic formula that you should know for refractive index. Next, third one guys, third important formula. Same for refractive index. There are many formula for refractive index. Third, mu 1 2. What is this? We will read this as refractive index of medium 2 with respect to medium 1. Again guys, we will read this as refractive index of medium 2 with respect to medium 1. This means that light is traveling from 1 to 2, but we read like this. Light is traveling from 1 to 2. Formula, what is formula for this? Simple, it is V1 upon V2, V1 upon V2 or mu 2 upon mu 1. Okay, so it becomes this form. Mostly they will ask numericals from this formula. Okay, na? Refractive index. Example, I will give a good example. For example, refractive index of this is water, this is air, this is glass. Simple, I will write as VA upon VG or mu G upon mu A. Get the answer. Understood? You will take like this. It becomes easy for you guys. Then fourth formula guys. Fourth, mu, again refractive index is lambda upon lambda medium. In exam they will be asking you light is traveling from one medium, rarer medium suppose, to denser medium, so you will see the path will change. Okay, so for this light we have a wavelength, but wavelength also changes when it goes to this medium, so we have to find the wavelength for second medium. Light is traveling from 1 to 2, rarer to denser. We know the wavelength over here, we need to find the wavelength over here. How can you find? This formula. Mu is lambda upon lambda medium. Lambda upon lambda, whatever the medium will be. Okay, so we will write this formula. Fifth, mu is equal, mu 1 2, matlab refractive index of 2 with respect to 1 will be 1 upon refractive index of 1 with respect to 2. This is called as reversibility of light. This is called as reversibility of light. What do you mean by reversibility of light? I will tell you. Check this out. Check guys. Imagine, like simple. Imagine light is traveling from medium 1 to medium 2. It is refracting. We placed a mirror over here, plane mirror. So the light will reflect back. Suppose it is falling at 90 degree over here. It is falling at 90 degree over here. So light will fall, reflect back and come to the same path. That's why I am saying that refractive index of medium 2 with respect to 1, matlab light is traveling from 1 to 2 will be equal to 1 upon refractive index of medium 1 with respect to 2, because it is coming in the same path. It will travel the same path. This is called as reversibility of light, and this is the formula for that. Okay, so this is for refractive index, guys. What happens usually, student gets confused for these formulas, these two formulas. This is one, and this is 2. These two formulas, student gets confused and they don't remember these formulas. They think majority of time they will ask this in exams, in practice also, in MCQs also, but they lose marks in these formulas. So you have to remember this formula, guys. Next, sixth, same refractive index, guys. Mu is 1 upon sine C. 1 upon sine C. What is C? C is called as critical angle, guys. C is called as critical angle, which is fixed, guys. If you know, we know that critical angle is fixed. If you will say glass ka, it will take 42 degree. Water ka, we will take 49 degree. Sometimes they will give you for different glass the different critical angle. Water ke liye sometimes they will give you 48 degree. But I want you to consider this degrees, that is 42 and 49 if they have not given. Okay? So this is the formula. Mu is 1 upon sine C. They will tell you to find, they will give you critical angle, they will tell you to find refractive index or vice versa. Okay? Next, seventh, guys. Same formula for refractive index only. And this is the last formula for refractive index. I said the 7 to 8 formulas. Last, that is real depth upon apparent depth. Real depth upon apparent depth. What is real depth? Simple, guys. I will tell you what is real depth. What you guys can do whenever I'm teaching you or I'm taking a lecture. So if you don't have much time, you can fast forward my lecture, increase the playback speed, and you can watch the video and write all your formulas. Okay? So it becomes easy for you also. Again, guys, see, for example, a man is sitting inside the water. Rarer medium, above is rarer medium. This is rarer medium. And this is rarer. And this is denser medium. Water. Okay? So light is traveling from rarer to denser. You will see an object is kept over here and person is seeing the object over here because of refraction. Because of refraction. So this distance is called as real depth, RD. And from here to here is real depth. But where we are seeing is called as apparent depth, AD. This is real depth, the actual object we are seeing over here, that is apparent depth. So object shifts from here to here. This is called as shift. This is called as shift. The object is shifting from this point to this point. That's why the first formula is refract. You have derivation for that. Right now they have given you, but it is not included in your portion. So you will write directly the formula. Mu is RD upon AD, that is real depth upon apparent depth. What is RD? RD is called as real depth, actual where the object is, and AD is apparent depth, where we see the object. This is apparent depth. Okay. So from this we also get to know one more formula, guys. Formula number 8, that RD will be AD plus shift. Hai? This is AD, this is shift. So if you add both of them, we will get real depth. So real depth is AD plus shift. So mostly in exam they will ask you shift. So you can put this over here, RD minus AD. So RD minus AD is shift. And last from this, for this topic, that is 9th, the formula is mu. They will ask you sometimes shift. So shift will be equal to RD 1 minus 1 upon mu. Shift will be RD 1 minus 1 upon mu. I know this is derivation. So you guys don't have derivation. I will tell you in shortcut. Okay? So how we can tell you? How we can get to know? Simple. See. So shift, as I said, shift is RD minus AD. RD minus AD shift. But I know mu is RD into AD. Put the value over here. Put the value over here. And AD will be RD minus what is AD? RD upon mu. Therefore RD will be 1 minus 1 upon mu. So here comes the derivation. You guys don't have derivation, but understand how it comes. Okay? So this is shift. Exam they will ask you the shift. Okay? Now they will tell you questions like the object is raised. Raised matlab shift. Okay? Exam they will ask you if object is raised. Again, student lose marks in this numerical because they don't understand the question. Okay? The shift will be RD 1 minus 1 upon these 3 important formula for shift. Next, still there are many formulas, guys. Next, 10th. Angle of prism. Angle of prism, guys. Okay? Simple. You guys know कि the light is, this is prism basically. Okay? So prism में light is traveling incident ray. This is refracted ray. This is normal. This is normal. This is emergent ray. We take this as I1. We take this as I2. This is angle of prism A. This is R1 and this is R2. Refracted angle R1, R2. And this whole angle, guys, this whole angle, this we say as angle of deviation. Light was supposed to go like this, but now light is going like this. So this angle, like this, light was going supposed to go like this, now light is going as a. So that this angle we will take is called as deviation, angle of deviation. Understood na? See, this is angle I1, angle of incidence, this is I2. तो लाइट को ऐसा जाना था, बट अब वो ऐसा जा रहा है, तो ये जो एंगल है, ये एंगल को भी कॉल इट एज एंगल ऑफ डेविएशन, गाइस. ठीक है? तो इसके देयर आर डेरिवेशंस फॉर फॉर्मूलाज फॉर एंगल ऑफ डेविएशन. यू गाइस डोंट हैव डेरिवेशंस, सो जस्ट राइट द फॉर्मूलाज. फर्स्ट, the formula is del plus A is equal to I1 plus I2. Del plus A equal to I1 plus I2. ठीक है ना? del is angle of deviation. Angle of deviation. A angle of prism. I1 angle of incidence. I2 angle of emergence. You should know this. ठीक है? Next, 11th. Del minimum, guys. You will see the most of the time they will be ask you minimum deviation. When can you get this minimum deviation, guys? The formula is 2i minus a. Simple. When I1 is equal to I2. When angle of incidence is equal to angle of emergence. When both are equal, so we will consider this as I. So I will write I plus I1 plus I2 as I plus I. It is 2i. A will come over here to 2i minus a. But when both are same, we will get minimum deviation. Iska if I make prism ka diagram, I will get like this: 1, 2, 3. Incident ray, refracted ray, no, emergent ray. But for this, if I am making the diagram, I will get like this, guys. Means see, this is parallel to the base. This is not parallel. Parallel कब होता है? जब वो minimum हो. Minimum का केस क्या है? When I1 is equal to I2. Understand this. ठीक है? Very important formula. And there are two more formulas. Usually they don't ask question from this, but we can write. Del will be del 1 plus del 2. दो एंगल देंगे deviation का. We have to find angle of deviation. Add them. A will be R1 plus R2. A angle of prism. This is A again. R1, ये R1 हो गया, ये R2 हो गया. Add both of them, R1 plus R2, है ना? R1 plus R2. If you will see, you'll get the answer. है ना? If you will see, put over, you'll directly get the answer. Put R1, put R2, del 1, del 2 put करो, आ जाएगा. ठीक है? del 1, del 2 का भी वैल्यू देते हैं, दो डिविएशंस. मोस्टली ये नहीं पूछ सकते, will ask you 10 and ये वाला फॉर्मूला. Let us suppose this as 12, 13. Understood? So I guess you have these 13 formulas for refraction through plane surface. है ना? इतने ही 13 is enough. Okay. ठीक है? Next. Understood? We'll move on to next chapter, guys. The chapter number 5, 5th chapter, refraction through lens. ठीक है? Very less formulas. Again, guys, very less formulas. But remember, I will give you a short trick. Just listen. Number 1, 1 upon V minus 1 upon U equal to 1 upon F. What is UVF? Simple. If this is lens, a lens है suppose. ठीक है? Optical center, first focus, center to F1, F2, second focus to F2. ठीक है? If suppose, guys, I am keeping an object over here, getting image over here. ठीक है? So object and this is image. Object का optical center से distance is U. Image का optical center से distance is V. Focal length F. कभी भी always we take focal length as F2 only. तो this becomes the focal length. Convex में भी focal length F2 है. Concave में focal length F2 ये side में आता है. If you see the diagram, तो always F2 is the focal length. Keep this in mind. तो 1 upon V minus 1 upon U equal to 1 upon F. ठीक है? Number 2, magnification. Magnification simple होता है, बताता हूँ कैसे होता है. Formula is V by U या I upon O. I क्या है? Height of image या height of object. High upon हो, high upon हो ना, height of image, height of object. Magnification. What is magnification? Simple है. Magnification मुझे I can get as 1, I can get a less than 1, I can get greater than 1. If I am getting magnification equal to 1, it is called as same size. Less than 1, diminished. Greater than 1, magnified. Are you getting, guys? The formula. Third, understood only 3 formulas for this. And the last formula is power. Power is 1 upon F. Power होता है diopter में. Focal length होता है मीटर में. फोकल लेंथ होता है मीटर में गाइस, ठीक है। पावर इन डायोप्टर, फोकल लेंथ इन मीटर, ठीक है। डन। तो दिस 3 formulas फॉर रिफ्रैक्शन ऑफ लेंस। अब ट्रिक बताता हूं गाइस, ध्यान से सुनो, ट्रिक बताता हूं, लिसन केयरफुली। ट्रिक्स, ये ट्रिक क्या होता है, यूजुअली व्हेन वी सॉल्व न्यूमेरिकल्स, व्हेन वी आर सॉल्विंग न्यूमेरिकल्स, सो दे डोंट गिव यू प्लस साइन माइनस साइन, ठीक है। वी हैव टू राइट प्लस साइन माइनस साइन बाय नोइंग द साइन कन्वेंशन। अब होता क्या है साइन कन्वेंशन, लेट अस अंडरस्टैंड गाइस। साइन कन्वेंशन क्या होता है, चेक दिस आउट। साइन कन्वेंशन, साइन कन्वेंशन इजी है, ठीक है। दिस इज लेंस, if we take object or any if any distance is taken on the left hand side, we take as negative. Any distance we take right hand side is taken as positive. Distance I am talking about, ठीक है। कोई भी, हाँ I am talking about lens. Lens से left is negative, lens से right is positive. Again principal axis, उसके ऊपर height, ऊपर positive, नीचे negative. मतलब if you are getting erect image, upright image, it's positive. If you are getting inverted image, it's negative. Same for this also, concave, ठीक है। So for that you, I know, अभी example देखो, for example take convex lens. Convex lens में guys you have total 6 cases, है ना। So from case 1 to 5 and case 6. For case 1 to 5 guys, you will see always object is on left hand side to negative. From 1 to 5 image right hand side में मिलता है तो V will be positive, right hand side. Focal length as I said f2, convex का focal length कभी भी right hand side f2 होता है तो ये भी positive. Easy, UVF. Case 6 guys, केस 6 में अलग होता है, U इज नेगेटिव, ऑब्जेक्ट लेफ्ट हैंड साइड, इमेज भी लेफ्ट हैंड साइड में आता है तो नेगेटिव हो जाएगा, एंड फोकल लेंथ इज पॉजिटिव। व्हाई आई एम टेलिंग दिस गाइस, व्हेनेवर दे विल गिव यू एनी क्वेश्चन और एनी कंडीशंस, ठीक है, तो यू हैव टू टेक सिंबल। दे विल गिव यू ऑब्जेक्ट इज 20 सेंटीमीटर इन फ्रंट ऑफ लेंस, you won't write 20 centimeter, you will write -20. So this shortcut will help you to give minus or plus sign when you're solving the numerical. They won't give you minus or plus at all. You have to write like this. So this is some shortcut. One more guys, concave lens. What is concave lens? Simple, we have two cases, case 1 and 2, only two cases. Simple, all negative, U negative, V negative, F negative, negative family. हमको पॉजिटिव रहना है गाइस, ठीक है ना, एग्जाम के लिए लाइफ में यू हैव टू बी पॉजिटिव, सो डोंट बी कॉन्केव लेंस, ठीक है, कोई नहीं, वी यूज कॉन्केव लेंस गाइस, दिस लेंस कॉन्केव लेंस, कॉन्केव कॉन्वेक्स लेंस, ठीक है। सो U negative, V negative, F negative, put this in formulas and then you will get the answer. Done. I will share you one more trick, one last trick for these chapters, that is magnification. Guys, magnification when I am talking about, एक तो magnification आएगा real and inverted image आएगा, या आएगा virtual and erect guys, they are partners. Real and inverted कभी भी आया, magnification is always negative. Why? It is coming down ऐसा, inverted image, magnification. वो इरेक्ट ऑलवेज पॉजिटिव, ठीक है। ये साइन भी देखा तो यू विल गेट टू नो कौन सा केसेस होता है कौन सा नहीं, ठीक है ना। सो दिस हेल्प्स यू। नेक्स्ट, पावर। गाइस, पावर का फॉर्मूला यू नो, 1/f। 1/f मतलब 1/ फोकल लेंथ होता है, ठीक है ना, है ना। 1/f हमने देखा था, फोकल लेंथ इज ऑलवेज इन मीटर, नॉट इन सेंटीमीटर, ऑलवेज इन मीटर। तो पावर फोकल लेंथ पे डिपेंड है। कॉन्वेक्स का फोकल लेंथ क्या था, कॉन्वेक्स का फोकल लेंथ पॉजिटिव था, तो पावर भी फॉर कॉन्वेक्स लेंस इज पॉजिटिव। फॉर कॉन्केव का पावर इज ऑलवेज नेगेटिव। क्यों? वाई रीजन? इसका फोकल लेंथ भी पॉजिटिव है, फोकल लेंथ भी नेगेटिव है। है ना, P is 1 upon F. You'll get to know this. Exam may tell you, they will ask you, P is power is minus 2D. Tell which lens we are using. Minus मतलब concave lens. कम, ठीक है ना. अच्छा 2D तो नहीं होना चाहिए, कम ही होना चाहिए, ठीक है. Still understood? तो ऐसा करके आ सकते हैं. They will ask you this. Then so remember this shortcut. This shortcut will help you कि lens में how to solve the numericals. Next guys. हाँ 6 चैप्टर है ना, स्मॉल चैप्टर, ज्यादा फॉर्मूलाज नहीं है. चैप्टर नंबर 6 स्पेक्ट्रम. स्पेक्ट्रम में गाइस इतने फॉर्मूलाज नहीं है, 2 और 3 फॉर्मूलाज है, वो भी यूजुअली है नहीं, बट आई एम गिविंग. नंबर 1 v इज इक्वल टू एफ लैम्डा, यू नो स्पीड ऑफ लाइट, एयर जो भी मीडियम में. f को बोलते हैं फ्रीक्वेंसी, लैम्डा को बोलते हैं वेवलेंथ, है ना, लैम्डा को बोलते हैं वेवलेंथ. याद रखने का. समटाइम्स व्हाट हैपन, द वेवलेंथ का वैल्यू दे विल गिव इन यू इन नैनोमीटर. 1 नैनोमीटर यू शुड नो इट्स 10 एंगस्ट्रॉम यूनिट. यूजुअली एंगस्ट्रॉम यूनिट में भी देते हैं, नैनोमीटर में भी देते हैं. एंड व्हाट इज 1 एंगस्ट्रॉम यूनिट? 1 एंगस्ट्रॉम यूनिट इज 10⁻10 मीटर. ठीक है ना. So if they will give you nanometer, they will ask you in Armstrong, or they will give you in Armstrong unit. You have to convert into meter to get the answer, to multiply by 10⁻10 meter. Then number 2 guys, I guess number 2 है नहीं इसका, v equal to f lambda, है ना. और क्या रहेगा, यही फॉर्मूला बेसिकली, या फ्रीक्वेंसी का फॉर्मूला नहीं, इतना ही रहेगा. एक ही फॉर्मूला यूजुअली, स्पेक्ट्रम में डोंट हैव दैट मच फॉर्मूला, सो यूजुअली ये फॉर्मूला ही यूज हो. और एक फॉर्मूला है, इट्स नॉट अ फॉर्मूला बट न्यूमेरिकल्स यूजुअली नहीं आता है, बट स्कैटरिंग आता है गाइस, या इंटेंसिटी. स्कैटरिंग का बात करें या इंटेंसिटी का बात करें, इफ आई एम टॉकिंग अबाउट स्कैटरिंग, ठीक है, इंटेंसिटी हो गया, इट इज इनवर्सली प्रोपोर्शनल टू लैम्डा रेज़ टू 4. जितना ज्यादा वेवलेंथ उतना कम स्कैटर होगा. रेड लाइट मोर वेवलेंथ, लेस स्कैटरिंग, है ना. वायलेट लाइट लेस वेवलेंथ, मोर स्कैटरिंग. इसलिए वी सी स्काई ब्लू, रीजन ये, ठीक है. तो स्कैटरिंग या इंटेंसिटी गाइस सेम होता है, याद रखना. तो देयर इज नो मच फॉर्मूला फॉर दिस चैप्टर, ठीक है. स्पेक्ट्रम. एंड लास्ट चैप्टर गाइस, अगेन आई डोंट वांट टू टेक मच टाइम बिकॉज आई नो दैट यू हैव वेरी लेस टाइम. तो जितना होता है उतना जल्दी मैं तुमको लास्ट चैप्टर का फॉर्मूला लिस्ट देता था. साउंड अगेन वेरी लेस फॉर्मूला फॉर साउंड. नंबर 1 सेम v इक्वल टू एफ लैम्डा. इसमें वेलोसिटी स्पीड ऑफ साउंड है, नॉट लाइट, ठीक है. f यू नो फ्रीक्वेंसी, लैम्डा. नंबर 2 v इक्वल टू लैम्डा अपॉन t. t is called as time period guys, है ना. v is lambda upon t. Why lambda upon t? Because we know that frequency is 1 upon time. Frequency is 1 upon time. तो frequency की जगह पे 1 upon time लिख दिया, तो ये फॉर्मूला आ गया. अंडरस्टूड. तो ये बेसिक फॉर्मूला है, दे विल आस्क यू, ठीक है. ये बेसिक फॉर्मूला गाइस, दे विल आस्क यू, है ना. फोर्थ अब ये फॉर्मूला है गाइस, इस पे मैक्सिमम न्यूमेरिकल्स आता है. इसको बोलते हैं v is 2d upon t. ये है, दिस इज फॉर्मूला फॉर एको, है ना. एको क्या होता है, व्हाई 2d? सिंपल एक डायग्राम के थ्रू आई विल एक्सप्लेन यू व्हाई वी आर यूजिंग 2d गाइस, है ना. चेक दिस आउट. भाई ये सर्जरी को देखो, व्हाट दिस सर्जरी इज डूइंग, साउंड, ठीक है. ये साउंड आ रहा है, माइक, आई डोंट नो इट्स माइक और समथिंग, माइक है. माइक इज क्लैपिंग. व्हेन दिस इज क्लैपिंग यू विल सी गाइस, साउंड इज ट्रैवलिंग, इधर जा रहा है, ये डायरेक्शन में जा रहा है, तो डिस्टेंस d. अगेन इट विल रिफ्लेक्ट दिस सरफेस एंड कम बैक, अगेन d, d plus d, 2d. इसलिए इसको एको का फॉर्मूला बोलते हैं. एको इज बेस्ड ऑन रिफ्लेक्शन ऑफ साउंड. V इज 2D/T. समझ में आ रहा है? तो ये बहुत इंपॉर्टेंट होता है गाइस. ठीक है, एको का कंफ्यूजन होता है डायरेक्ट वेलोसिटी का फॉर्मूला में, दैट इज डिस्टेंस अपॉन टाइम, या एको के फॉर्मूला में. यू शुड नो बेसिकली, यू शुड सॉल्व सो मच न्यूमेरिकल्स दैट यू कैन डिफरेंशिएट बिटवीन एको का न्यूमेरिकल एंड डायरेक्ट बेसिक न्यूमेरिकल. ठीक है, सो दिस इज एको एंड आई गेस फिफ्थ one more formula guys they will be asking in numericals, that is frequency f1 L1 is equal to f2 L2. again L length of कोई भी string ले लो, चलो string ले लो, ये कोई और लेंथ है, दूसरा स्ट्रिंग का लेंथ है, कंपेयर करो, है ना. फ्रीक्वेंसी इज ऑलवेज इनवर्सली प्रोपोर्शनल टू लेंथ. So if we take f1 L1 equal to f2 L2, we get this equation. They will ask you numericals for this formula. f1 L1 is equal to f2 L2. ठीक है, easy for string हो गया, vibrating column, air column हो गया, सबके लिए we will see कि ऐसा होता है. Sixth, loudness L1 upon L2 equal to A1 square upon A2 square. What is A1? A1 and A2 they are called as amplitudes. या एम्पलीट्यूड हो गया. L is called as loudness. तो they will give you two amplitude, A1 देंगे, A2 देंगे, बोलेंगे कंपेयर करो, कंपेयर करके हमको क्या मिलेगा, लाउडनेस का हमको कंपैरिजन मिल जाएगा, रेशियो मिल जाएगा. ये क्वेश्चन पूछते हैं साउंड में गाइस. दे विल गिव यू एम्पलीट्यूड्स और दे विल गिव यू लाउडनेस. उल्टा भी होता है, लाउडनेस देंगे, दे विल टेल यू टू फाइंड एम्पलीट्यूड, तो उसका क्या करना है, स्क्वायर रूट लेना है, दोनों साइड से स्क्वायर रूट लेना है. एम्पलीट्यूड दिया तो व्हाट यू विल डू, यू विल स्क्वायर. जैसे A1/A2 दिए 1/3 2/3, तो लाउडनेस क्या होगा, इसका स्क्वायर A1 स्क्वायर अपॉन A2 स्क्वायर, दैट इज 2 स्क्वायर 4 3 स्क्वायर 9. दिस आंसर, राइट, इजी. और दे विल गिव यू loudness का रेशियो as 9/16. now we have to find L1 upon L2, फॉर्मूला पता है, A1 स्क्वायर अपॉन A2 स्क्वायर, रूट ले लो, दोनों साइड स्क्वायर रूट निकालो, तो L1/L2 रूट में आ गया इजी. रूट ऑफ 9/16 क्या होता है गाइस, तो रूट ऑफ 9/16 3/4 आंसर आया. I will get 3/4. Understood? तो they can ask you either this one or the other this one. आता है क्वेश्चन में, एग्जाम में आता है गाइस, they will ask you this. ठीक है, so these are the main formulas for sound. There are more formulas guys, but I guess they won't be asking in numericals, they will be asking in theory questions. So I will give you some more formulas. This will be for some theory questions. ठीक है, first frequency is 1 upon, for pendulum also they will ask you. Okay, frequency is 1 upon 2 pi root of G upon L, है ना. frequency is 2 pi root of G upon L. L को बोलते हैं effective length. This is for pendulum guys. This is for simple pendulum. 9th में you had this chapter या you had this topic simple pendulum का, है ना. तो इसका सिर्फ रिलेशन पूछेंगे, एक्सेलरेशन ड्यू टू ग्रेविटी, लेंथ का. 8 F is 1 upon 2L root of T upon pi R square D 2L, सॉरी, स्ट्रिंग के लिए, है ना. स्ट्रिंग एग्जाम्पल गिटार का हो गया, ठीक, गिटार का एग्जाम्पल, वायलिन का एग्जाम्पल, जो स्ट्रिंग्स होते हैं, है ना. इट इज इनवर्सली प्रोपोर्शनल टू लेंथ, डायरेक्टली प्रोपोर्शनल टू टी, जो तुम लोग देते हो गाइस, टेंशन. आर हो गया रेडियस, है ना. यू विल गिव यू टेंशन, टी आर रेडियस, उसका रिलेशनशिप देखना, विल गेट द आंसर क्या है. अंडरस्टूड? ठीक है, तो यूजुअली ये दोनों फॉर्मूलाज आते हैं. ठीक है, हाँ. एंड लास्ट गाइस, लास्ट फॉर्मूला. ठीक है, अगेन दिस इज फॉर थियरी, दिस थ्री फॉर्मुलाज आर फॉर थियरी गाइस. ठीक है, सो यू डोंट हैव टू वरी, यू डोंट हैव टू टेक टेंशन, यू डोंट फॉर दैट ये बाहर करके जाना है, नहीं, बस थियरी के लिए तुमको याद रखना है गाइस. ठीक है, लास्ट फॉर्मूला 9th. ठीक है, फॉर्मूला सेज दैट एफ इज 1/2 पाई रूट ऑफ के अपॉन एम. ये किसके लिए होता है? ये बेसिकली स्प्रिंग मास के लिए होता है. कोई भी मास को उठा रहे, स्प्रिंग होता है, स्प्रिंग से उठा रहे. दिस इज के इज कॉल्ड एज स्प्रिंग कांस्टेंट, है ना. यू हैव टू रिमेंबर द रिलेशन फॉर थियरी. एम इज बेसिकली लीनियर डेंसिटी बोलते हैं, वी कॉल दिस एज लीनियर डेंसिटी, दैट इज मास पर यूनिट लेंथ. याद रखना है, ठीक है ना. मास दिया तो मास, चलो मास याद कर लो तुम, यू जस्ट रिमेंबर मास फिलहाल के लिए, इससे ज़्यादा तुमको पूछेंगे नहीं. रिमेंबर दिस एज मास, है ना. सो दिस थ्री फ्रीक्वेंसी फॉर्मूला फॉर थियरी क्वेश्चंस गाइस. दे विल आस्क यू 1 और 2 मार्क का वन लाइनर्स एमसीक्यूज, या सेक्शन ए में इसका क्वेश्चन आ सकता है. ठीक है, अंडरस्टूड. सो आई विल सजेस्ट यू टू रीड ऑल दी formulas that I have made you given you over here, and also note it down guys. It is very important for you to note it down and keep revising. If possible थोड़ा फास्ट फॉरवर्ड करके देखना, so that तुम्हारा टाइम भी बचे. ठीक है ना. एंड आई होप आई हैव गिवन ऑल दी formulas, I have not missed any formulas. In case I will just update in my upcoming lectures. And in case if you have not seen my previous lecture guys, that is प्रीवियस वीडियो जिसमें फोर्स, वर्क पावर, एनर्जी, मशीन का मैंने एक रिवीजन दिया लास्ट मिनट. गो एंड चेक एंड मेक योर रिवीजन लिस्ट. ओके, सो ऑल द बेस्ट, सी यू इन नेक्स्ट लेक्चर. बाय गाइस.